Good morning to all respected professor, my fellow classmates, everybody present here. My name is Abbas Ali, student of BTech, 8th semester aeronautical engineer at University Department, Rasan Technical University, Kota. Today I am here to present topic of my seminar presentation on reusable launch system under the guidance of Mr. K.S. Bhatti. So let's start the first slide. What is reusable launch system? A reusable launch system RLS referred to a system which can be used for several missions. A reusable launch system is that space analog of an aircraft. Ideally, it takes off vertical on the back of an expendable rocket and then glides back down the like an aircraft. During landing phase, an RLS can be either land on a runway or a platform swing. The main advantage of RLS it can be used multiple times. So with low serving cost, the expendable rocket that is used for launching the RLS can also be designed to use multiple times. A successful RLS will surely cut down mission cost and make space travel more accessible. Next slide. Before RLS, the part which moved at very high velocity shared into smaller parts pieces while entering the Earth's atmosphere and are usually made of light and thin aluminum. Some small parts go around orbit of Earth, which increases debris in low orbit. When the booster run out of fuel, they are detected from the rest of the rocket, usually with some kind of small explosive charge, and fall away. The first stage the burns the competition and falls off. Next slide, history. The thoughts of reusable launch system started in 1950s, but seriousness of attempts in completely reusable launch system started in 1990s. The most prominent were the McDonnell Douglas DC-8 and the Lockheed Martin X-33 venture starts. Next slide. Today, SpaceX is a recent player in the private launch market, successfully converting its Falcon 9 expendable launch system into a partially reusable system by returning the first stage for reuse. Government space agencies such as NASA, ISRO, ECA, and Roscosmos are also deploying in the field of RLS for future space missions, which will make it more affordable. On 22 November 2015, Blue Orbit New Shepard rocket became the first proven vertical takeoff vertical landing rocket which can reach 100.5 kilometers. Design of RLS. Body. The body has to withstand very high static as to cope with the rapid change in the temperature which hangs from minus 250 Celsius in shade to 250 Celsius in direct sunlight. Wings. Delta wings provide enough lift to fly the space and also reduce the friction during re-entry. Cockpit. Cockpit has double pane glass window which can withstand the force of light and pressure and vacuum. Oxygen bottles are used to add breathways and an absolute system removes the excellent carbon dioxide. Electric power. The power required is taken from lithium batteries which could be charged if needed by using solar energy. Next slide. This is the design of RLS. Next slide. Working of in RLS. At supersonic and supersonic stage, it goes up to about 1 lakh feet and 30 kilometers. It uses a combination of a convention of jet engine and ramjet engine. The plane is accelerated to a speed of Mach 4 and Mach 5 at hypersonic stage at an altitude of about 1 lakh feet and a velocity of about 4 Mach 4. And combustion and ignition take place in milliseconds. Stage jet engine take RLS to Mach 15. At space stage, rocket engine are fired and there is not enough oxygen for scramjet engine and RLS is accelerated to Mach 25. Rocket engine take RLV to payload release site and required operation are performed. At re-entry stage, RLS perform re-orbit operation and slow itself down. It drop to lower orbit and enter upper atmosphere layers. RLV used to aerodynamics to glide down once it reaches dense air. Next slide. This is the takeoff and landing diagram of SpaceX Falcon 9. Next slide. Now concept of RLS. Next slide. Stage 2 orbit. Single stage 2 orbit. SSTO reaches the space orbit carrying small payload of 9,000 to 20,000 kg without losing any hardware to LEO. Two stage 2 orbit are two independent vehicles which which while launching Crossfit has two or three similar stages are stacked side by side and burn in parallel. They carry heavy payloads to outer space. Next slide. Vertical landing. Parachute could be used to land vertically either at CA or with the use of small landing rockets on lands. Rockets could be used to soft land the vehicle on the ground from the subsonic speed region at the low altitude. This typically requires about 10% of the landing weight of the vehicle to be propelled. Alternately, auto gyro and helicopter rotor is required for a 2 to 3% of the landing weight for the rotor. Next slide. This is the sum figure of RLE vertical landing. Next slide. Retro-propulsion and backward propulsion. Retro-propulsion means firing your rocket engine against your velocity vector in order to decelerate. The vehicle fired its rocket toward the surface to the slow the craft descent after parachute had already brought it below the speed of sound. It is very expensive in the sense that the fuel required for landing must be carried to space, which erodes the usable payload capacity of launch system. Next slide. This is the economy of reuse diagram. In this figure, we can easily see that cost of first stage rocket engine is too much compared to the cost of second stage engine. Next slide. The conclusion. First conclusion is highest development cost and technical risk. Second one is technologies within the current state of art. Third one is more promising than ever before. Fourth one is cost for launching become much cheaper as it reduces material cost due to reusability. Fifth one is the future RLS should be constructed with low cost and use cryogenic engine for all stages. Next slide. Any questions?
Yes, what is the future of reusable rockets?
Reusable rockets are in general safer, more cost effective and allow for cheap development for much needed manufacturing of satellite. Its revenue are projected to surpass $6 million by 2027 at an 8% compound annual growth rate for the period of 2020 to 2027. Any further questions?
No, thank you.
Thank you. Have a nice day.